Welcome all to this last course, to this last module on this course, Econometrics. Today, we'll be rounding up with review and future directions in econometrics. By way of module objectives, we'll be looking at summarizing the major econometrics concepts covered in the course and explain how they apply to real-world policies and business questions. We'll be looking at describing recent developments in econometrics and using the use of machine learning methods, big data, and modern forecasting systems. And we'll also be looking at explaining emerging trends such as econometrics or in the digital economy, real-time data analysis, and modern forecasting systems. We'll also be looking at evaluating the strengths and limitations of combining econometrics with machine learning and identify when interpretability and casual identifications matter most. Lastly, we'll be developing a career plan as an economics professional, including technical and skill building, portfolio development, and professional communication. By way of introduction, econometrics is the toolkit that allows economists, analysts, and policy professionals to convert data into credible evidence. Across the earlier modules, they have learned how to specify modules, estimate parameters, interpret trends, test modules, and diagnose common economic problems, such as multiplicity, heteroscedasticity, autocorrelation, and indigeneity. We have also worked with specialized frameworks for cross-sectional time series and panel data. And you have seen how softwares make it possible to apply theory to real data sets. Module 10 provides two connected groups. First, it consolidates key ideas covered in the course, emphasizing how the pieces fit together as a practical workflow. They are defining research questions, collecting and clean data, choosing an identification strategy, estimate and validate a model, and communicate results to decision makers. Second, the module looks forward. The frontiers of econometrics physically interact with machine learning, big data infrastructure, real-time analytics, and new data sources such as digital platforms, satellite imagery, mobile money records, and administrative microdata. The future of applied econometrics will reward economists who can combine discipline, clear assumption, valid identification, and careful inference with modern computational skills. This module introduces recent developments and emerging trends, and also provides career guidance on building a professional profile as an economist. What is the complete workflow? First, it defines research question, we collect and clean data, we choose your identification strategy, estimate and validate a model, we communicate results responsibly. This is the model for predicting versus causal inference. Let's look at machine learning economics. What does it do? Machine learning focuses on prediction accuracy. Lasso selects variables in their dimensions. Tree models captures non-linearity. Causal ML combines flexible prediction with value difference. Regularization and model specification. This is the diagrammatic representation. What about big data and high-dimensional econometrics? Opportunities here is granular insights and rare event analysis. The risk is overfitting and multiple testing. The solutions here is regularization and dimension reduction. Ethics and responsible data use. This protects privacy and sensitive information. It uses reproducible scripts and version control. There is document assumption and data transformation. Non-linear and structural modules. That is logic and probit for binary outcomes. Spline and semi-parametric models. The structural models allows counterfactual simulation. Let's look at a case study here. Consider a microfinance institution deciding whether to expand credit to first-time borrowers. This institution has two distinct questions. One, practical creative question. What applicants are mostly or are most likely to default? Two, casual question. Does offering a lower interest rate reduce default and increase payment performance? For the creative question, ML models can be trained on historical repayment data using cross-validation to evaluate out of simple performance. Accuracy, AUC, and calibration curves are the key metrics here. For the casual question, a randomized pilot that is offering lower rates in random subjects or credible quasi-experimental design, e.g., regression discontinuity based on score threshold is needed. Even if ML is used to model outcomes, the identification strategy must justify casual interpretation. This case illustrates why method choice depends on the decision problem, not only on data availability. Let's look at some of the emerging trends in economics. Emerging trends are shaped by digital transformation of economics and growth of real-time data. Digital footprints from e-commerce platforms, mobile devices, social media, and payment systems produce new measures of behavior. At the same time, organizations want faster insights, not quarterly reports, but dashboards that regularly update daily or hourly. These trends expand what economists can study and how quickly they can respond. But they also demand stronger governance, data governance, careful handling of biases, and new forecasting framework that perform well under the structural breaks and rapid change. They include one, digital economic data, two, real-time analytics, three, modern forecasting under structural change. Let's look at econometrics in digital economy. Digital economy creates novel research questions, that is, platform competition, algorithmic pricing, online advertising effectiveness, network effects, and the economics of data and privacy. Econometric analysis in this setting often uses granular event level and requires methods that handle selection biases and strategic behavior. A common challenge is that digital systems are adaptive. When a platform changes the recommendation algorithm, users respond. Sellers adjust prices and data generating processes shift. Econometricians therefore pay close attention to treatment timing, staggered adoption designs, and methods robust to dynamic treatment effects, e.g., event study frameworks and modern difference estimator. Experimentation is also common in digital context. A/B testing provide randomized variation, but economists must still be careful with interference. The strongest applied for combined experiments with theory. Let's look at the next here. We have the real-time analytics challenge. Real-time data analysis uses high-frequency indicators to infer economic conditions before official statistics are released. This practice is often called nowcasting. Examples include using payment to track consumption, satellite lights to track economic activity, or online job posts to track labor demand. Nowcasting system usually combines pipelines that ingest and clean data, statistical models that map indicators to target variables, and evaluation tools that compare performance time across time. Because high-frequency data can be noisy, robust methods and smoothing techniques are frequently used. Let's look at forecasting and structural change. Forecasting is not only about fitting history, it's also about anticipating the future under uncertainty. Model forecasting often uses ensemble that is combining multiple models to reduce risk. For instance, a forecasting system may blend arithmetic models, dynamic factors, and ML approaches such as gradient boosting. Structural change is a central challenge. Policy reforms, pandemics, conflicts can alter economic relationships. When break occurs, model trained on historical data may fail. Practical responses include Rowindley estimation, break detection test, time varying, and scenario analysis. A key professional skill is to judge when a model is good enough for a decision. Sometimes a simple benchmark performs well and easy to use. In other cases, complex models offer large gains. The Economics' role is to match model complexity to the cost of error and the need for transparency. Mini project example. Let's look at inflation nowcasting. Suppose you want to nowcast monthly inflation using weekly and daily indicators such as food prices. And practical workflow is data, collect high frequency series. For futures, compute weekly averages, growth rate, and lag values. Compute models, compare dynamic factor model. Do an evaluation, use a rolling origin evaluation to mimic real-life forecasting. Then carry out communication, provide a nowcast to certain bands. Now, going over to building a career in economics. Economists operate in environments where evidence shapes policy, investment, and public discourse. As such, ethical responsibility is integral for professional practices. Ethical conduct includes honesty about uncertainty, careful distinction between autocorrelation and all of that. Continuous learning underpins sustained success. Econometric method evolve, software tools improve, and new data source emerge. Staying current requires reading applied research, experimenting with technologies, and engaging in professional communities. Lifelong learning is not optional. It is essential in a field defined by methodological innovations. Now, some of the careers in economics include government and banks. In government, ministries, statistical agencies, and central banks, economists are directly involved in shaping public policy. Their work is closely related to macroeconomic stability, fiscal sustainability, labor market, public finance, and regulatory design. They carry out substantive effort to inflation forecasting and macroeconomic projections. They also carry out what they call monitoring of dashboard. These dashboards synthesize key economic indicators. This is what economists carry out in government and central banks. Now let's check. What about for consulting, finance and tech? For consulting, it shifts from public welfare to profitability, competitive positioning, and market performance. A common assignment here is they carry out market sizing, estimating the total potential demand for a product within a service or within a market. They also carry out what they call pricing analysis and demand estimation. For financial institutions, economic professionals work in risk analysis, they carry out asset pricing, portfolio management, financial stability assessment. They also carry out development of credit scoring models. Economists in the tech world, they conduct stress testing, they simulate how financial portfolios will perform under advanced macroeconomic scenarios, such as recessions, interest rates, and all. In technology, they also focus on the user behavior, platform design, algorithm evaluation, and product optimization. What are some of the common core across all this? Despite the sectorial differences, several expectations remain universal across economic careers. First, rigorous analysis is non-negotiable. Second, careful interpretation is essential. Third, reproducible execution ensures credibility. Fourth, ethical transparency underpins trust. Finally, effective communication transforms technical findings into meaningful decisions. In every sector, the economist's role is to fundamentally the same. That is, to reduce uncertainty through discipline analysis and to translate evidence into informed actions. By way of conclusion, this module reviewed the economic workflow and highlighted how the field is evolving. Machine learning and big data expands the economic toolkit, but they do not replace